Hello everyone, welcome back. So we have already seen the first part of this video, Q4, where the question was given the sum of beautiful subsequences. If you have not gone through, please go through. I have already added the code into this problem statement, right? In this video, you can say in the comment section, you can get it from there. Okay. And for now, let's begin with the part 2. What the question is saying that we have to find the GCD, right? Based on some given things. Let's talk about the sum of beauties first. So to find the sum of beauties, we need to find the GCD. So for all the GCD which is greater than or equal to 1, we have to do what? We have to find the increasing subsequence with the GCD which is exactly Z, right? So instead of directly finding the GCD, we can say exactly Z. What we need to do, the trick is for each G, we have to count the subsequences whose every element is divisible by 2. And we'll call this as a function of Z, we can say. So these subsequences have a GCD is a multiple of Z. So this is a little hard question, but if you stick to the approach that I'm going to explain, you will understand. Okay. So very first, what I told you, we have to find the sum of beauties. And for that, we can say for all the Z, means all the GCD which is greater than or equal to 1, we have to multiply Z into the number of GCD having exactly Z, right? So first trick is that for each G, we will count the subsequences whose every element is divisible by G, and we'll call this f of Z. And these subsequences have a GCD is multiple of Z, correct? And so we'll use the another trick we'll, in the same we'll use is use inclusion and exclusion, like Mobius inversion, right? Where we call G of Z is equal to f of Z minus the summation of k is greater than equal to G, sorry, k is greater than equal to Z, and we'll say G is what? Kz, right? Where G of Z is nothing but the subsequences with GCD exactly Z, and finally we'll compute sum of Z into GZ, and the Z is nothing but the GCD, right? Means the GCD, there will be a function that we will do. So we have to use inclusion and exclusion, right? Because this is the Mobius inversion and we used to use this technique. Okay. So for more this, let me know in the comment section that you understood this Mobius inversion or not. If you not, please go to some Google search. You will understand the Mobius inversion. So very first, what we need to do, we have to do pre-processing. So these are the steps that we are going to understand in the code that I have sent you in the comment box in the first part of the video. You can get the code from there. Very first step, what you need to do, you have to do pre-processing. So very first, you will take a max A, you will define as 0. So our purpose is to find the maximum value in the given array A, and so we'll use a max A. So next we will create a list, we can say. So this list will act as a will get from the array, right? And so we'll say max a plus 1, and it will store all the elements, the number from nums that are divisible by Z. Okay, so we'll store in this one. So we'll iterate over the value from I equal to 1 to max a, and what we will do, we'll do I plus plus, right? And we know that if V is greater than or equal to max a, we know that is the maximum number of elements, and that is why we are going for all the elements, right? You know the number was given, right? Like that. Then we'll build the divisor based list, and for that we will iterate over the nums, and we'll get the square root of the elements at the value. We'll get the lim, we can say, and from divisor 1 to will go to the limit, we can say, and we'll do plus plus, and we will find the divisor. We will keep adding all the divisor in the list. Otherwise we'll say other b by d, and if other not equal to d, we'll add on to the list and we'll add to the b. Okay, so you will add this is the purpose to build the divisor. So how we are going to do, let's suppose we have the numbers we have given 1 to 3, and for all the numbers in the given nums, we have to find the divisor of v, all the elements. And so we will add this element into the list of we can say divisor, and also the lists of v by d. So for every divisor z, and list of z is the subsequence of value that is divisible by the z. We can say, let's suppose we'll take the 1 to 3 first, then 2, and then 3, like that we can use, because 1 can we divide the any all of these elements, 2 can only divide the 2, and 3 can only divide the 3. In the next step, what we need to do, we have to count the strictly increasing subsequence in the list, and for that we'll start for z equal to 1 to, we'll go to the max, and we have the sequence. So we'll say if sequence is empty, we'll continue it, will not do anything else, and there will be a Fenwick tree will be used. Let's call this a bit, and we'll iterate over that. And for all the array elements, we'll find the, because this is just like a disjoint set, so we'll get the rank, and we'll find the smaller sums, then current, and we'll keep adding the element on the bit appendix. We'll keep adding onto the tree, and similarly we'll find the total. And then if your total is greater than the mode, we'll take the mode. Okay, and you will keep updating appendix at z, we'll find the total, right? This is the f of z, we can say. We'll find the value. So Fenwick tree is nothing but what? We are going to use here the Fenwick tree trick. So we want the number of strictly increasing sequence. So we will iterate in the order, right? Because array is equal to sequence, we can say. So for each element x, we have the smaller sum, and we'll do bit dot sum, will do index minus 1 will do, and we'll find the maximum number. We will find the number of sequences which is ending with a smaller value. So each sequences ending which is at x is either at x, and alone we have to extend all the smaller subsequences. We will keep updating the Fenwick, and we'll say bit, keep adding this value. So total will get accumulated number of increasing in the list, and at the end we'll say f of z is nothing but, we'll keep adding the number of strictly increasing subsequence with all the elements which is divisible by k. For example, if we have f of 1, we'll say 7, because all subsequence of we will divide 1 to 3 will get divided by 1. So we'll say f of 1 is nothing but 7. F of 2 is nothing but 1, because this is 2. F of 3 is 1 coming, because just 3, like that we can say. Now we will use the inclusion and exclusion, right? So we'll get the exact GCD counts, we can say, and we'll iterate over this, and we'll get the GCD. We know how to count the GCD. Then we'll process the big to the small, and for that we'll start with the z at z and f of z, like that. Let's suppose, for example, we want to extract we will not extract, we want to subtract all the subsequences which is already counted in the multiple times. So for that, we'll let's suppose GCD 3, and it is both are 1, like that. G and f both are coming 1, right, in GCD type. If we'll do the minus, what is coming the value, we'll get the 5. 7 minus 1 1 1, we'll get the 5. Now we have to compute the beauty sum. You know how to compute the beauty sum. You will multiply this, you will take the mod, and you will get the answer. So each time we have to multiply, like we know the GCD, it is going 5 times, 1 times, 2, and 1 times, right? We will multiply all of these, you will get the total value is 10 that we have seen. This is how we are going to use the Fenwick tree class. So we'll use the n and the bit, Fenwick will use, and this is what we have to do. We'll use the add method, and this is your sum method. And Fenwick tree is the efficient sum prefix sum, will do plus, and will update in O log n times, and that is why it is very famous. So the summary is, we will use the list of z, number of divisible by z, then if I am the increasing number of subsequence in the list which is divisible by all the divisor, and GCD will GCD is nothing but the GCD exactly z, which removes the multiples using the inclusion declusion, and we will find the answer using z into z. Okay, so I'll try to cover everything, but still if you have any doubt, let me know in the comment section. And for each slides, please pause and go through by yourself in your rhythm, in your space, right, in your pace, we can say, so you will understand each topics clearly. Okay, keep writing your notes, that will help you in building your strength. Thank you guys, thank you for watching this video. I'll put this video and I'll try to put the code also in this video. And if you have anything else, let me know in the comment section. Thank you.